Alright, so this particular video we're talking about the systems of equations with elimination challenge. Before we go and do this problem, we're going to do another student's problem right now. I'm going to see if he can tell me exactly what it says. Could you please tell me exactly what it says so I can write up here on the board? Tell me what it says. Negative 2x plus 5y equals 13. Now what does the bottom equation say? 16x plus 3y equals 25. Now what we're going to do is we're going to take this top equation and we're going to multiply everything by an 8. We're going to multiply everything by an 8. Now 8 times negative 2 is negative 16x. Okay? And 8 times 5 is 40y. And now we're doing 8 times 13. Alright, 8 times 13 is 104. Alright, so we're going to put 104. When we do this, we are literally going to be adding these equations together because we're eliminating all the x values. So that zeroes out. We get a total of 43 y's equals a total of 129. So I'm going to take 129, divide it by 43, and I get 3. So if I divide both sides by 43, I get y equals 3. Now once you solve for one variable, then you just take it and plug it in. So I'm just going to plug it in this bottom equation right here. Alright, so I'm going to take 16x, I'm going to add 3 times, instead of the y value, I'm going to take that 3, I'm just going to plug it in and set it equal to 25. So we get 16x plus 9 equals 25. And then we just solve for x. So we just take away 9 from both sides. We get 16x equals 16. And of course you can see x is equal to 1 if you divide both sides by 16. So we get x equals 1. So his answer that he would need help with is x equals 1 and y equals 3. Okay? You bet. Now, what we're going to do now is we're going to take a look at my problem, which this one's a little bit trickier. Alright, so here's what we got. We have 5x minus 4y equals negative 10. Now some of my students realize I'm doing a recording and they're being very respectful and staying quiet, while other students are oblivious to me doing a recording and they just keep talking no matter what because they're just all about themselves. Alright, I'm not going to call anybody out, but that's what happens sometimes. So, right now, what we're going to do is we have to choose what we're going to eliminate. Alright, so I eliminated the x's on the last one, so I'm going to go ahead and eliminate the y's on this one. So here's what I'm going to do. I am going to put a parentheses around the first equation and the parentheses around the second equation. And in your journal, if you're doing this, go ahead and write the word eliminate y. We're going to eliminate the y's. So like I said earlier, in this particular problem, we're going to eliminate y. I had to put the video on pause because we're switching class periods. So right now, if we wanted to eliminate y's, that means I got to get rid of all of the y's. In the previous problem, I eliminated all of the x's. Alright, in this problem, I'm going to eliminate all of the y's. So what we have to do is we have to take a very close look at this negative 4 and this positive 5. That's what we're going to be looking at, this negative 4 and positive 5. Now you'll notice if you add these together, they will not eliminate. The only way they would eliminate is if they're the exact same number. Like this was a 16x and then the additive inverse is negative 16x, and that's why they eliminated. So what we have to do is we have to find what's called the least common multiple between a 4 and a 5. Now if you don't remember least common multiple, it's very, very easy. Just let's count by 4s. Ready? 4, then 8, then what? 12, then 20, right? And then 24, it keeps going on forever. We count by 5s, it's what? 5. Oh, I apologize. There's 16. There we go. 16, 20. We got 5, 10, 15, 20, 25. All right, so right now, can you guys see the 20? That's called the least common multiple between a what? 4 and a 5. So that's going to really help us in our elimination strategy. Okay? So right here, if I put a 4 here, no, my bad, I'm thinking about the x's again, sorry. If I put a 5 here and I put a 4 right here, look what happens when I distribute a 5 throughout this entire expression. So we got 5 times 5, which is 25. And then we get 5 times negative 4, which is negative 20. Then we get 5 times negative 10, which is negative 50. Then if we distribute the 4 throughout the entire equation, you get negative 16x. 4 times 5 is 20. And 4 times 8 is 32. Now the whole purpose of me multiplying the top equation by a 5 and the bottom equation by a 4 is for this to happen right here. Now I have a negative 20 and I have a positive 20, and when we add the two equations together, what happens to everything? It just, these zero out. Now we do have a certain amount of x's still left. We have 25 minus 16, which is a total of 9 x's. And if we take negative 50 and we add, negative 50 and we add 32, that gives us negative 18. And so we have what? 9x equals negative 18. Yeah. And after we divide both sides by 9, we get what? X equals negative 2. So that's one of our answers. So right here, one of our answers we're going to type in is negative 2. Well, wait a second. How do we solve for y? Well, you have a choice. Okay, you guys have a choice. You guys can either use this equation, all right, or you can use this equation. So what do you guys want? You guys want the top equation or the bottom equation? Bottom? Okay, let's do the bottom one, all right? So negative 4x plus 5y equals 8. Now what number am I going to plug in for our x right there? I'm going to plug in a negative 2. There we go. So negative 4. Open up a big old parentheses. Plug in a negative 2. Interesting. So we got what? Negative 4 times a negative 2 is an 8. Huh. So if you're thinking ahead, what are we going to subtract both sides by? Oh, so look what happens. Everything what? Zeros out. So what are we left with? 5 times a number equals 0. So what does y have to equal? Has to equal 0. So even if you divided both sides by 5, it would still equal 0 if you just kept doing the process. Those cancel out, and y is equal to 0. And that's what I'm going to write in. Let's go quickly. I'll go over it real quick. Won't take long. Let's take a look at what we did. So we multiplied the top equation by a 5 and the bottom equation by a 4. Why? So that we get these to be additive inverses. So when we add them together, we get 0. Then we solved for x. We got x equals negative 2. Then we took that little negative 2 right there and we plugged it in right here and we solved for our y. And that's all you got to do. Negative 2. 0. And we say, yay, we got it right. Okay. Now, if you get one wrong, you could just go what? See step-by-step solution. Now, they may have eliminated the x's instead of eliminated the y's. Okay, so I'm going to see what they did. Oh, no, what did they do? They eliminated the what? The y's as well. Okay. Well, you know what? Sometimes in life you might want to eliminate your x. So on this one, well, the y's are easier, so we'll just eliminate the y's again. All right, maybe in the next problem, eliminate x. So if you guys would please go ahead and write this down. I have a lot of female students right now that are shaking their head. Yes, they would like to eliminate their x's. All right, they're like, please, totally want to eliminate their x. All right. If you want to know how to eliminate x's, all right, or how not to eliminate your x's, you feel free to watch the ID channel. That'll show you like all the wrong ways of doing it where you get caught. Okay. I'm just kidding. You really shouldn't eliminate your x's. I'm just joking. So please do not feel like I'm condoning that at all. All right. So let's go ahead and write these down. You know what? Let's change. I'm going to change colors. Just because. Okay. Now listen. what I want you guys to understand, do not do this. We're gonna eliminate the y's again. But if you wanted to eliminate x, this is what you would have to do. You would have to take the top equation and the bottom equation, and on one of them you'd have to multiply it by 3 and the other one a 7, but you'd have to make one of these negative, okay? Because right now, what's 3 times negative 7? Negative 21. What's 7 times negative 3? Negative 21. So you'd have to either make this one negative to change it to a positive, or you have to make this one negative to change it to a positive, if we wanted to eliminate all of our x's. But we're not going to eliminate all of our x's, okay? We're going to eliminate the y's. Why am I going to choose the y? Because I can easily get to a what? A positive 10. What would I have to multiply the bottom equation by to get to a positive 10? Negative 2, you're right. So what I'd like you to do, can you please take the bottom equation and multiply everything by a negative 2. So a negative times a negative is a positive. Negative times a negative is a positive. Negative times a positive stays a negative. And watch what I'm going to do. I'm going to take the blue equation. I'm just going to put it right underneath it, carefully writing it down, nice and neat, keeping things organized to make our life easier. The better you organize your problem, the easier it will be. If you're really messy and just throw things wherever you want them and it's not organized, you're not going to be very accurate or precise. All right, so we're going to add these equations together. What happens when we add a 6x minus a 7x? What do we get? Negative 1x, right? These, what happened? All these zero out, correct? They all zero out. And what are we left with here? Negative 50 plus 45 is negative 5. Now, what happens when you get a negative x equals a negative 5? What will x have to equal? What do you guys think? Now, if you're not sure, you can do a couple of different things. You can either multiply everything by a negative, all right? Or what else could you do? You could divide everything by a negative 1. And what do you get? X equals 5. So right now I know x is equal to a positive 5. Okay. Wow. Which equation do you guys want to use? You guys want to use the top equation or use the bottom one? Okay, let's use the bottom one. So I'm going to rewrite the bottom equation right here. Negative 3x minus 5y equals 25. Okay. Negative 3x minus 5y equals 25. Now, what are we going to plug in? We're going to take what? X equals 5 and plug it in right there. So negative 3, parentheses, what am I plugging in? I'm plugging in a 5. There we go. All right, here we go. Negative 3 times 5 is negative 15. Now we're just going to solve for y. What do we have to add to both sides?
15.
Add 15. Good. These zero out. What am I left with? Negative 5y equals a total of 40. So what do we have to divide both sides by? Negative 5. There we go. And what is our y value going to equal? Negative 8. So now I have my two answers. I got a 5 and a negative 8. Now, if you wanted to check your answers, okay? If you wanted to check your answers, we got a 5 and a what? 5 and a negative 8. So what could you do to check them is just what? Plug in a 5 and plug in a negative 8, okay? So this becomes 80 minus 35, which is 45. And you plug in what? Plug in a 5 and a negative 8 and see if it works out to a 25. So it's 5 and a negative 8. Just checking, just making sure I didn't mess up. 5 and negative 8. Okay, I feel a lot better. Here we go. Boom, got it. So that's what you're doing, okay? Sometimes you're going to have to eliminate the x. Sometimes you're going to have to eliminate the y's. It depends, all right? You just kind of choose the easiest path. Why did I eliminate the y's? Because the easiest path was to multiply the bottom equation by a negative 2 so that the y's would eliminate. Okay, that's it.